So for today's gas of the day, we're going to be studying the ideal gas law. And this is going to be a new situation because of the fact that we will not be studying two different conditions. With the past three gas laws, you had an initial set of conditions and a final set of conditions. So you had, for example, a P1 and a P2. And now we're just going to be studying one set of conditions. So the first bullet there just says, what if you want to know the conditions of a gas right now? Not a before and an after like we've been dealing with. So if that was the case, you'd need to know 3 of 4 variables: pressure, temperature, volume, and now the new thing that we are going to be working with is amount. Amount means how much gas we have present. In all of the previous gas laws, we have had the amount of gas being held constant. That means we haven't been pumping more gas in or letting any gas escape. The name ideal gas law means that the gases are behaving ideally. And that just means they're behaving in a way that really all gases don't behave, but in a way that makes our math a little easier, and we can make some assumptions that allow us to look at these mathematically and follow some certain laws. So just follow along with the math and it'll be a little easier. So getting back to our variables, pressure, temperature, volume, and amount. Another tricky part of this is you need to make sure that volume, pressure, amount, and temperature are always in correct units. Pressure, we're going to want them to be in kPa, or make sure you add this in. We're going to allow you to keep them in atmospheres either, but you're going to have to keep this in check, one or the other, but make sure which one you have, that you are for sure which one you have. Volume has to be in liters, so make sure you know that. If you have milliliters, you have to convert it to liters. How do you do that? You move your decimal three, 2. So if you had, for example, 350 milliliters, that would be 0.350 liters. So you move it 3 to the left. Temperature has to be in Kelvin. That shouldn't be anything new. Remember, Kelvin is degrees Celsius plus 273 will give you your Kelvin. And now again, back to our new one, amount. The unit for amount has to be in moles. However, a lot of times you won't find it in moles. You'll find it in grams. So how do we get between moles and grams? This should be popping into your head. You have to use molar mass. So if you are given grams, remember, grams to moles. Remember, you throw your molar mass in there. So you divide by your molar mass. All right, so the ideal gas law is PV equals nRT. So let's restate this. P has to be in kPa or atmospheres. Volume has to be in liters. N has to be in moles. And T has to be in Kelvin. So what about that R value? R is what's called the universal gas constant. And it is what pulls all of these other variables together and relates them. Now, your value for R is either going to be 8.31, and the unit is liters times kPa over moles times K, or 0.0821 liters times atmospheres over moles times K. So let's break that down a second here, and let's look at which part of that unit is different, and it's the pressure unit. So if you are using your pressure unit of kPAs, you're going to use the R value of 8.31. If you're using atmospheres, you're going to use the pressure value of 0.0821. So you just have to match it up, whichever one fits. All right, so again, how do you know that you're going to use the ideal gas law? The difference is going to be that they mention amount. So that means they're going to mention moles or grams. That's how you know that this is different. How else would you know? Because they're only going to mention one set of conditions. So when you read through the problem, if they don't mention pressure twice, if they don't mention volume twice, they don't mention they don't mention temperature twice, they only mention one set of conditions, or they mention moles or grams, you know it's probably going to be the ideal gas law. All right, so we're going to break this up into 2 videos. The next video is going to be just your practice problems.